Hello everyone, welcome to National Standard Examination in Physics 2010. Displacement of an oscillating particle is given by y equal to a sin bx plus ct plus d. The dimensional formula for ABCD is: y is displacement of the oscillating particle. From the principle of dimensional homogeneity, a should be displacement. X is displacement, so b is L power minus 1, t is time, so c is t power minus 1, d is a constant, so it is m naught, L naught, t naught. So the dimensional formula for ABCD is m naught, L naught, t power minus 1. Two small spheres of equal mass start moving in opposite directions from point A in a horizontal circular orbit with tangential velocities v and 2v respectively. Between collisions, the spheres move with constant speeds. The number of elastic collisions the spheres will make before they reach point A again is: as the collision is elastic and the masses are equal, the velocities will be exchanged after every collision. Before first collision at B, second sphere travels 2/3 of the circumference and first sphere 1/3 of the circumference. Now the first ball acquires a velocity 2v and the second ball gets a speed v. So they collide at point C. At this point the velocities are again exchanged, so they move back to point A for the third collision. So two collisions take place before the spheres reach point A. On one arm of an inclined plane, 5 hooks are fixed at same separation to lift the upper arm relative to the other arm kept horizontal as shown. The hook fixed on the inclined plane is lifted through the same angle with the help of a spring balance using hooks 1, 2, 3, 4, 5 in order. A graph is plotted between the reading of spring balance and distance of the hook from the hinge of the inclined plane. The graph that correctly represents this variation is: identical point masses are placed at n-1 vertices of a regular polygon of n sides. The vacant vertex has a position vector a bar with respect to the center of the polygon. Therefore, the position vector of the center of mass of the system is: when all the point masses are present, the center of mass will be at the center of the polygon. Since one mass is missing, the center of mass will shift away from the missing corner. Effectively, there are n-2 point masses at the center and 1 point mass at the opposite corner to the vacant corner. So XCM equal to m1x1 plus m2x2 by m1 plus m2. Upon simplification, we get the position of center of mass to be minus a bar by n-1. Three identical balls moving together along a horizontal line with velocity v collide with two similar balls at rest along the same line. The collision is elastic. After the collision, two balls move with velocity v, two balls move with velocity 3v by 2, three balls move with velocity v, three balls move with velocity 2v by 3. The masses are equal and the collision is elastic, so the velocities are exchanged. Two balls originally at rest start moving with velocity v. Two balls out of the three will come to rest because of the velocity exchange. One out of the three balls will continue to move. Effectively, three balls will move with velocity v after collision. A block is placed on a surface with vertical cross section given by the equation y equal to x square by 20. If the coefficient of friction is 0.5, the maximum height above the ground at which the block can be placed without slipping is: slope of the vertical cross section y equal to x square by 20. dy by dx we can write as 2x by 20, that is x by 10. So the slope tan theta, that is dy by dx equal to x by 10. Coefficient of friction mu equal to tan theta, that is 0.5. From the above expressions we get x equal to 5. So the height at which the block can be placed without slipping is h equal to 25 by 20, that is 1.25 meter. Let L be the length and D be the diameter of cross section of a wire. Different lengths of wire of same material are subjected to same tension. In which of the following cases will the tension be maximum? Extension produced in the wire E equal to FL by AY. Here F and Y are same for all the wires. So E is proportional to L by A. E is proportional to 4L by pi D square. So E is proportional to L by D square. Verify the values of L by D square for all the 4 wires. We get the correct option to be D. Consider an expression F equal to AX sin BT, where F is force, X is distance, T is time. Dimensionally, the quantity AB represents. B2 should be a number, so B equal to 1 by T, that is B is T power minus 1, its dimensional formula. AX should be force, so A equal to F by X, so the dimensional formula A comes out to be mt power minus 2. Multiplying A and B, we get it as mt power minus 3. Now let us write the dimensional formulas of the options one by one. Energy is ml square T power minus 2, surface tension mt power minus 2, intensity of light mt power minus 3, pressure is ml power minus 1 T power minus 2. So the correct option is C. Velocity displacement curve of a particle moving in straight line is as shown. Line PB is normal to the curve and line PA is normal to x-axis. The instantaneous acceleration of the particle at P is acceleration of the particle A equal to dv by dt, that can be written as v times dv by ds. dv by ds is the slope of the velocity displacement graph. So slope of the graph at P equal to negative slope of normal at P. So slope of PB, which is a straight line, comes out to be minus 4. So the slope of the curve will be 1 by 4. Instantaneous acceleration of the particle at P is v times dv by ds. So that comes out to be 4 into 1 by 4, 1 meter per second square. Suppose that gravitational force varies inversely as nth power of the distance. The time period of a planet in circular orbit of radius r around Sun will be proportional to. When an object is in circular path, it requires a centripetal force. The centripetal force for the circular orbit of the planet around the Sun is provided by gravitational force. So F centripetal equal to F gravitational, mr omega square equal to gmm by r square. Here it is r power n. So from there omega square equal to gm by r power n plus 1, from which we get t proportional to r power n plus 1 by 2. A planet of mass m moves around Sun of mass capital M in an elliptical orbit. The maximum and minimum distances of the planet from the Sun are r1 and r2 respectively. Therefore, the time period of the planet is proportional to. Apply Kepler's third law. T square is proportional to r cube for circular orbit. So here T square is proportional to a cube for elliptical orbit. Maximum distance r1 equal to a of 1 plus e. Minimum distance r2 equal to a of 1 minus e, where a is eccentricity of the ellipse. Adding the above two expressions, we get a equal to r1 plus r2 by 2. So applying Kepler's third law, we get t square is proportional to a cube. So t square is proportional to r1 plus r2 whole power 3 by 2. One mole of an ideal gas is taken from an initial state A P0 V0 to a final state B 2 P0 2 V0 by two different processes. The process 1, gas expands isothermally to double its volume and then pressure is doubled at constant volume to the final state. Process 2, gas is compressed isothermally until its pressure is doubled and then its volume is doubled at a constant pressure to the final state. The PV diagram that correctly represents the two processes is process 1 isothermal, that is constant temperature. PV relation is a hyperbola, that is stage 1. In process 1 isochoric process constant volume, PV relation is vertical straight line, that is stage 2. Process 2 isothermal process constant temperature, PV relation is a hyperbola, that is stage 1. In process 2 isobaric process, that is constant pressure, PV relation is a horizontal straight line, that is stage 2. In the circuit shown, the potential difference across C1 and C2 respectively. Capacitors offer infinite resistance to DC. The current flows through 400 ohms, 100 ohm and 500 ohm. Current through the circuit I equal to V by R, that comes out to be 2 milliampere. PD across C1 is PD across 400 plus 100 ohms resistances, which comes out to be 1 volt, and PD across C2 is nothing but potential difference across 500 ohm and 100 ohms resistances, which comes out to be 1.2 volt. A ball is dropped from a height h above a horizontal concrete surface. The coefficient of restitution for the collision is E. The time after which the ball stops bouncing is. Time taken before the first bounce, t equal to root 2h by g, since it is a freely falling body. The time between first and second bounces will be t12 equal to 2 times root 2h by g into E. The ball will stop after making n collisions theoretically. So the total time equal to t1 plus t2 plus so on tn. So it is t equal to root 2h by g plus 2 root 2h by g into E plus 2 root 2h by g into E square, so on. Now simplifying this, we get the time taken for the complete stopping of the ball to be root 2h by g times 1 plus E by 1 minus E. A metal block is resting on a rough wooden surface. A horizontal force is applied to the block is increased uniformly. Which of the following curves correctly represents the velocity of the block? The block will remain stationary till the applied force is equal to the limiting friction. The net force on the block when it starts moving, F equal to Kt minus Fk kinetic friction. So Ma equal to Kt minus mu k into N, from which we obtain an expression for dV that comes out to be k by m t minus mu k times n by m into dt. Upon integrating on both sides, we get V equal to k by m t square by 2 minus mu k times n by m into t plus c, where c is constant of integration. Now putting the initial conditions at t equal to 0, V is 0, we obtain constant of integration to be 0. So finally we have V equal to k by m t square by 2 minus mu k times n by m into t. It is in the form of y equal to at square minus bt, which is the equation of a parabola. So the correct option is 3. The earth has mass m1 and radius r1. Similarly, the sun has mass m2 and radius r2. Distance between their centers is small r. It is known that the center of mass of the earth-sun system lies well within the sun. Therefore, center of mass of earth-sun system xcm equal to m1x1 plus m2x2 by m1 plus m2, that comes out to be m1 small r by capital M1 plus m2. Since the center of mass of the sun earth system lies inside the sun, xcm is less than r2, where r2 is radius of sun. So from where we get the condition that m1 by m1 plus m2 is less than r2 by small r. Consider a particle of a rigid body. Its motion can be described by vectors r bar, omega bar, ar bar, at bar and alpha bar. The symbols have their usual meaning. Then which of the following equations is incorrect? Angular acceleration alpha equal to d omega by dt. Angular velocity, rate of change of angular displacement, omega bar equal to d theta bar by dt. Linear velocity equal to angular velocity into position vector. So we get v bar equal to omega bar cross r bar. Radial acceleration ar bar equal to v square by r. That can be written as omega bar cross r bar. Tangential acceleration at bar equal to dvt by dt, that is d by dt of omega bar cross r bar, that comes out to be alpha bar cross r bar. So the correct option is B. 3 energy levels A, B and C in an atomic system are such that EA is less than EB less than EC. If the wavelengths corresponding to the transitions C to B, B to A and C to A are lambda 1, lambda 2 and lambda 3 respectively, then energy levels of the atomic system EA less than EB less than EC. Wavelength for the transition C to B is lambda 1, B to A is lambda 2 and C to A is lambda 3. The energy relation is ECA equal to ECB plus EBA. That is HC by lambda 3 equal to HC by lambda 1 plus HC by lambda 2. That gives us lambda 3 equal to lambda 1 lambda 2 by lambda 1 plus lambda 2. The refracting angle of a prism is A and refractive index is cot A by 2. The angle of minimum deviation is refractive index of the prism mu equal to sin A plus D by 2 by sin A by 2, where D is angle of minimum deviation. Cot A by 2 equal to sin A plus D by 2 by sin A by 2. Upon simplification, we get angle of minimum deviation equal to 180 minus 2A. Refer to the arrangement of logic gates for A equal to 0, B equal to 0 and A equal to 1, B equal to 0, the values of output Y are respectively. Output of the AND gate is AB. Output of NOR gate is A plus B whole bar. These two outputs are fed to OR gate. So Y equal to AB plus A plus B bar, that comes out to be AB plus A bar B bar, which is nothing but exclusive NOR gate. Now for the given inputs, we get the corresponding outputs to be 1, 0. A plastic ring of radius r has a charge plus 3q distributed uniformly along 1/4 of its circumference and a charge minus q uniformly distributed along the rest of the circumference. The potential on the axis at a distance √3 times r is, where r is the radius of the ring. Potential due to charged ring V equal to 1 by 4 pi epsilon naught q by root of r square plus x square. Potential is a scalar quantity. So the potential due to positive charge is 1 by 4 pi epsilon naught 3q by 2r. Potential due to negative charge is 1 by 4 pi epsilon naught minus q by 2r. Upon adding them algebraically, we get the net potential to be 1 by 4 pi epsilon naught q by r. The figure shows 4 orientations at angle theta with the magnetic field B of magnetic dipole with moment m bar. The magnitude of torque tau and potential energy U is best represented by magnitude of torque on the magnetic dipole tau equal to mb sin theta. Tau 1 is mb sin 180 minus theta. Tau 2 is mb sin theta. Tau 3 is mb sin 360 minus theta. Tau 4 is mb sin 180 plus theta. Coming to potential energy of the magnetic dipole, U equal to minus mb cos theta. So U1 equal to minus mb cos 180 minus theta. U2 equal to minus mb cos theta. U3 equal to minus mb cos 360 minus theta. U4 equal to minus mb cos 180 plus theta. So the second option is the correct one. A cylindrical vessel contains a liquid of density ρ filled up to height h. The upper surface of the liquid is in contact with a piston of mass m and area of cross section capital A. A small hole is drilled at the bottom of the vessel. The speed with which the liquid comes out of the hole is neglecting viscous effects. Apply Bernoulli's theorem between the piston and the hole at the bottom, taking the hole at the bottom to be reference level. P0 plus half rho v square equal to P0 plus rho gh plus mg by A. Half rho v square equal to rho gh plus mg by A, which gives us velocity equal to root of 2g times h plus m by rho A. A charged capacitor discharges through a resistance R. Let U be the energy stored in the capacitor and let P be the rate at which energy gets dissipated. Then the time constant is time constant of discharging RC network tau equal to RC, that is the time taken for the charge to reach 37% of the initial steady state value. Energy stored in the capacitor U equal to half CV square. Rate of dissipation of energy is V square by R. Taking the ratio, we get tau equal to 2U by P. The following figure shows different arrangements of two identical pieces of plano-convex lenses. The refractive index of the liquid used is equal to that of glass. Then the effective focal lengths in the three cases are related as. Let the focal length of each plano-convex lens be f. The first combination f1 equal to f by 2. The second combination f2 equal to f by 2. The third combination f3 equal to infinity. You can go through the lens formula in each combination. So none of the options is correct. A long wire carrying a current 1 ampere is placed along the axis of a long hollow tube of radius 5 cm, also carrying a current of 1 ampere in the same direction. The magnetic field at a distance of 2.5 cm from the axis is. Magnetic field due to straight current carrying conductor B equal to mu naught by 2 pi I by R. That comes out to be 8 into 10 power minus 6 Tesla. Radius of the cylindrical tube is 5 cm, while the distance of consideration is 2.5 cm. So the point inside the cylinder does not have any magnetic field due to the current in the cylinder. So only the wire will contribute the magnetic field. So the correct option is 8 into 10 power minus 6 Tesla. A uniform solid sphere of mass m has a radius capital R. The gravitational potential at a distance small r, which is less than capital R, from the center of the sphere is. This problem involves a little bit of mathematics and integration. So potential at a point inside the sphere V equal to negative of work done to bring the particle from infinity to P by mass. This integration process can be divided into two parts. One is from infinity to the surface of the sphere, another one is from surface to the point of consideration P. That is minus 1 by m integral infinity to r fdr plus integral capital R to small r fdr. Go through the process of integration carefully. If possible, do it on your own. The final answer comes out to be minus gm by 2r cube times 3r square minus r square. The focal length of a concave mirror is f. An object is placed at a distance x from the focus and forms a real image. Therefore, the magnification is. Applying mirror formula 1 by v plus 1 by u equal to 1 by f. 1 by f plus x plus 1 by v equal to 1 by f, from which we get v equal to f of f plus x by x. So the magnification m equal to size of the image by size of the object, that is image distance by object distance. That comes out to be f by x. A photon of wavelength lambda less than the threshold wavelength lambda naught is incident on a metal surface of work function W naught. The de Broglie wavelength of the ejected electron of mass m is. Applying Einstein's photoelectric equation E equal to 5 plus k max, we get hc by lambda equal to W naught plus k max, from which we have k max equal to hc by lambda minus W naught. The de Broglie wavelength lambda equal to h by mv, that is h by root of 2mk. So the final answer comes out to be h by root of 2m into hc by lambda minus W naught. In the following VT diagram for a perfect gas, the relationship between P1 and P2 is. Apply the ideal gas equation PV equal to nRT. From there V by T equal to nR by P. So V by T is proportional to 1 by P, where P is pressure. Slope of graph V by T is inversely proportional to pressure. From the figure, slope of P2 is greater than slope of P1, indicating that P2 is less than P1. A photographic plate placed at a distance 10 cm from a point source is exposed for 4 seconds. If the plate is moved farther away by 10 cm, the time required to have the same exposure in seconds would be. Intensity of light I equal to energy by area into time, that is energy equal to intensity into area into time. Intensity of light for a point source I equal to power by area A point source creates a spherical wavefront, so area will be 4 pi r square. So intensity I equal to energy by time into 4 pi r square. Exposure is defined as the amount of light energy collected in a given time. So the ratio of intensities I1 by I2 is R2 by R1 whole square, that comes out to be I2 equal to I1 by 4. So the exposure is constant. So I1 T1 equal to I2 T2, from which we get T2 equal to 16 seconds. The voltage over a cycle varies as V equal to V0 sin omega t for 0 less than or equal to t less than or equal to pi by omega, V equal to minus V0 sin omega t for pi by omega less than or equal to t less than or equal to 2 pi by omega. The average value of the voltage for one cycle is. The average value over positive half cycle V average equal to 1 by the length of the cycle, that is t by 2, integral 0 to t by 2 V0 sin omega t dt. That comes out to be 2V0 by t integral 0 to t by 2 sin 2 pi by t into t dt, which upon simplification comes out to be 2V0 by pi. The average value over negative half cycle will be minus 2V0 by pi. So over a complete cycle, the average value comes out to be 0. Young's double slit experiment is first performed in air and then by immersing the whole setup in a liquid. The 10th bright fringe when in liquid is formed at a point where 8th dark fringe is located when in air. The refractive index of the liquid is. Distance of mth dark fringe in air y dark equal to m plus a half lambda d by d. Distance of 8th dark fringe in air, so is 7 plus a half lambda d by d, that comes out to be 7.5 lambda d by d. Distance of nth bright fringe in liquid y bright equal to n lambda liquid d by d. Lambda liquid is lambda by mu. So the distance of 10th bright fringe will be 10 lambda d by mu into d. Given 8th dark fringe coincides with 10th bright fringe, so we get 7.5 lambda d by d equal to 10 lambda d by mu times d. Upon simplification, we get the value of mu to be 1.33. A spherical shell made up of metal of density ρ metal remains just below the surface of a liquid of density ρ liquid. If small r and capital R are respectively the inner and outer radii of the shell, then the ratio r by r is. Applying laws of flotation, the equilibrium condition, gravitational force equal to buoyancy force. So mg equal to m dash g 4/3 pi r cube minus r cube into rho metal into g equal to 4/3 pi r cube rho liquid into g. Upon simplification, we get small r by capital R, that is inner radius to outer radius equal to cube root of 1 minus rho liquid by rho metal. The ratio of magnetic field at the center of a current carrying circular coil to its magnetic moment is x. If the current and the radius both are doubled, the value of this ratio would be. Magnetic field at the center of the current carrying circular coil B0 equal to mu naught I by 2r. Magnetic moment of the current carrying circular coil m equal to I into a, that is I into pi r square. Given x equal to B0 by m, that is mu naught by 2 pi r cube. You can see this ratio is independent of current. So if radius is doubled, that is r dash equal to 2r, then x dash equal to mu naught by 2 pi into 2r whole cube, that comes out to be x by 8. A conducting ring of radius r is placed in a varying magnetic field perpendicular to the plane of the ring if the rate at which The magnetic field varies is x. The electric field intensity at any point of the ring is. Rate of change of magnetic field dB by dt is given to by x. EMF induced E equal to d phi by dt, that is area times dB by dt, which comes out to be pi r square into x. EMF induced E equal to integral E bar dot dl bar, that is E into 2 pi r. From the above two equations, we can write pi r square into x equal to E into 2 pi r, from where we get E equal to Rx by 2. Here we are dealing with the induced electric fields. Unpolarized light of intensity 32 watt per meter square passes through 3 polarizers. The transmission axis of the last polarizer is crossed with that of the first. If the intensity of light emerging out of the third polarizer is 3 watt per meter square, then the angle between the transmission axis of the first two polarizers is. Intensity of unpolarized light I0 equal to 32 watt per meter square. Transmission axis of the last polarizer is crossed with that of the first one. So, theta 13 equal to 90. Intensity of light coming out of the first polarizer is I1 equal to I0 by 2, that comes out to be 16 watt per meter square. Intensity of light coming out of the second polarizer I2 equal to I1 cos square theta 12, so 16 cos square theta 12. I3 equal to I2 times cos square 90 minus theta 12, since first and third polarizers are perpendicular to each other. The angle between second and third polarizer will be 90 minus of theta 12. Upon simplification, we get theta equal to 30 degrees. Two soap bubbles of radii 2r and 3r are in contact with each other. The radius of curvature of the interface between the two bubbles is. Excess pressure inside the soap bubble delta P equal to 4T by R, where T is surface tension. Pressure inside the smaller bubble P1 equal to P0 plus 4T by 2R. Pressure inside the bigger bubble is P2 equal to P0 plus 4T by 3R. Pressure difference between the two surfaces delta P equal to P1 minus P2, that comes out to be 4T by 6R. So the radius of curvature of the interface is 6R. A hoop rolls down an inclined plane without slipping. Then the inclined plane is smooth, the inclined plane is rough, and still there is no loss of mechanical energy. The point of contact of the hoop with inclined plane is always at rest. The linear speeds of different points on the rim of the hoop are different. The hoop is rolling without slipping. So in the case of pure rolling, point of contact is at rest. So no energy is lost due to friction. The inclined plane is rough and still there is no loss of mechanical energy. The point of contact of the hoop with inclined plane is always at rest, that is by the definition of pure rolling. The linear speed of different points on the rim of the hoop are different. Those speeds are indicated in the diagram. Which of the following phenomena is or related to the variation in density of atmospheric air? Mirage. In winter, sound of whistle of a railway engine is heard at much longer distances. Twinkling of a star, visibility of sun for some time after the sunset. Let us see the options one by one. The first option, mirage is due to variation of refractive index of layers of atmospheric air. In winter, the density of air is less, thus sound travels faster in such air. As light from the star enters the atmosphere, it undergoes refraction continuously, so the position of the star seems to be changing for an observer on the earth. As the light from sun enters the earth's atmosphere, it It bends downwards, thus showing the image of the sun for longer time. So all the above options are correct. The graph shows the displacement of a body as a function of time. Which of the following are the conclusions? The graph represents motion with constant velocity. The graph represents accelerated motion. The body comes to rest after a long time. The graph represents a retarded motion. As we can see from the diagram, it is a displacement time graph. Slope of displacement time graph gives you velocity as seen from the graph. Slope is initially positive and large, but as the time passes it decreases. So the velocity decreases with time. So the graph represents a retarded motion. The body comes to rest after a long time because it is an exponential rise curve. A transistor is connected in common emitter mode. The collector supply is 10 volt and voltage drop across resistor of 1 kilo ohm in the collector circuit is 0.5 volt. If the current gain beta is 49, then relation between common base current gain alpha and common emitter current gain beta is beta equal to alpha by 1 minus alpha, from which we get alpha equal to 0.98. Given collector current IC equal to VC by RC, that comes to be 0.5 milliampere. Common base current gain alpha equal to IC by IE, that is collector current by emitter current. 0.98 equal to 0.5 milliampere by IE, from which we get emitter current equal to 510 microampere. The variation of gravitational field intensity with the distance from center of a body is shown in the graph, from which one can conclude that the graph represents variation of gravitational field intensity with the distance from center of a uniform solid sphere. Eg equal to gm by r cube into small r. This is gravitational field intensity inside the sphere. You can see Eg is proportional to small r. And Eg equal to gm by r square. This is gravitational field intensity outside the sphere. When an alternating current flows through a circuit consisting of a resistor in series with a capacitor during the cycle at some time, it is possible to have voltage across the circuit 0, but current through it is not 0. Current through the circuit is 0, but the voltage across it is not 0. Current through the capacitor is not 0, but the voltage across it is 0. Current through the resistor is not 0, but the voltage across it is 0. Voltage across the circuit is 0, but the current through it is not 0. Current through the circuit is 0, but the voltage across it is not 0. When current through the circuit is 0, the potential drop across the resistor is 0, but the applied voltage appears across the capacitor. Current through the circuit is not 0, but the voltage across it is 0. Initially, when the circuit is switched on, the capacitor acts as short circuit, so the voltage across it is 0. As the charge builds up on the capacitor, the voltage increases across it. Current through the resistor is not 0, but the voltage across it is 0. The current wave and voltage wave are in phase with each other in the case of a resistor. So, it is not possible for non-zero current and zero voltage for a resistor. So, A, B, C are correct options. A detailed phasor diagram and waveforms are represented in the next slide. A person is sitting in a moving train and is facing the engine. He tosses up a coin which falls behind him. He concludes that the train is moving. When the person tosses the coin up, it will have two velocities. Velocity along x-axis is velocity of the train. Velocity along y-axis is velocity imparted by the person. The coin follows a parabolic path under the influence of these two velocities. Once the coin is in air, acceleration in horizontal direction is 0 and acceleration in vertical direction is minus g meter per second square. So the coin will fall into the hands of the person If the train's acceleration is also 0, that is, the train is moving with constant velocity. As the coin falls behind the person, the train should be either accelerating forward or decelerating backward. For an LCR circuit, A and B represent R and Z respectively. A and B represent Z and R respectively. A, B, C and D represent Z, XL, R and XC respectively. For omega equal to omega dash, the phase difference between the current and voltage becomes 0. Resistance is independent of frequency, so it is represented by the line C. Inductive reactance XL equal to omega L, so XL is proportional to omega, so it is represented by line B. Capacitive reactance is XC equal to 1 by omega C, it is proportional to 1 by omega, so it is represented by line D. Impedance of LCR series network is Z equal to root of R square plus XL minus XC whole square. So it is root of R square plus omega L minus 1 by omega C whole square. Impedance becomes a minimum, that is equal to R, when the frequency of the supply becomes equal to resonant frequency. Under resonance, the current wave is in phase with voltage wave. So the correct options are C and D. A furnace has two-layered wall as shown schematically. Each layer has the same area of cross section. The temperature theta at the interface of the two layers can be reduced by increasing the thermal conductivity of the outer layer, decreasing the thermal conductivity of the inner layer, increasing the thickness of the inner layer, decreasing the thickness of outer layer. The given combination is a series combination of the blocks, so thermal current is the same. dq by dt equal to delta theta by L by Ka. Here L by Ka is known as thermal resistance. So dq by dt can be written as 800 minus 80 by Li by Ki into A plus L0 by K0 into A for both the blocks. Rearranging the terms, we get theta equal to 800 minus 720 by 1 plus Ki L0 by K0 Li. So you can verify the options. All the four options come out to be true. Simple pendulums P1 and P2 have lengths L1 equal to 80 cm and L2 equal to 100 cm respectively. The bobs are of masses M1 and M2. Initially, both are at rest in equilibrium position. If each of the bobs is given a displacement of 2 cm, the work done is W1 and W2 respectively. Then, work done in displacing the bob is increase in potential energy, that is W equal to mgl of 1 minus cos theta. Taking the ratio, we get W1 by W2 equal to M1 by M2 into 4 by 5. From there, theta 1 is x by L1, that is arc length equal to radius into angle. We get theta 1 equal to 2 by 80, that is 0.025 radian, and theta 2 equal to 2 by 100, that is 0.02 radian. Assume that a constant power P is supplied to an electric train and it is fully used in accelerating the train. Obtain relation giving the velocity of the train and distance travelled by it as a function of time. Power supplied to the train P equal to F into V. From there F equal to P by V. F equal to MA. So MA equal to P by V, from which we get A equal to P by MV. Acceleration can be written as rate of change of velocity, so we get dv by dt equal to p by mv. Upon rearranging the terms and integrating, we get v equal to root of 2pt by m. For displacement, v equal to dx by dt, that is 2pt by m under root. From there dx equal to root of 2p by m t power 1 by 2 dt. Integrating on both sides, we get an expression for x as 2 by 3 times root of 2p by m t power 3 by 2. A block of mass 1.5 kg rests on a rough horizontal surface. A horizontal force applied to the block increases uniformly from 0 to 15 Newton in 5 seconds. Determine velocity and displacement of the block after 5 seconds. Use coefficient of static friction 0.6 and coefficient of kinetic friction 0.5 and g equal to 10 meter per second square. The limiting friction between the two surfaces, that is the maximum value of static friction, equal to mu static into m into g, which comes out to be 9 Newton. The kinetic frictional force between the two surfaces comes out to be 7 Newton. As the applied force increases linearly with time, we can write F equal to 15 minus 0 by 5 into t plus 0, that comes out to be F equal to 3t. Here we have applied the formula y equal to mx plus c. From the force equation, time taken for the force to reach 9 Newton is 3 seconds. So for the first 3 seconds the body is at rest. Then it starts moving. Resultant force on the object after it starts moving is F minus kinetic friction, that is 3t minus 7.5. So the acceleration of the object A equal to F by m, which comes out to be 2t minus 5. As we can see, the force and acceleration, both of them are time dependent. For finding velocity, we write dv by dt equal to 2t minus 5, from which we get v equal to t square minus 5t plus 6. I suggest you to pause the video for some time and go through the integration process. For displacement, we can write v equal to dx by dt, from where we get x equal to t cube by 3 minus 5t square by 2 plus 6t plus k, where k is constant of integration. Upon substituting initial values, we get x equal to 14 by 3 meter. A tower used for power transmission leaks a current I into the ground. Assume that the current spreads uniformly into the ground. Let ρ be the resistivity of the ground and r is the distance from the center of the tower, assumed to be a rod. The lower end of the rod is spherical with a radius b. Then determine current density as a function of r. Current through the conductor I equal to integral j bar dot dA bar. So from there I equal to j times 2 pi r square, which gives us j equal to I by 2 pi r square. Here 2 pi r square is the surface area of hemisphere. Magnitude of electric field at a distance r. Magnitude of electric field can be found from the relation J equal to sigma E, where J is current density, sigma is conductivity, E is electric field intensity. From there we can write I by 2 pi r square equal to sigma E, from which we have E equal to I by sigma 2 pi r square. 1 by sigma can be written as resistivity, so it is I rho by 2 pi r square. Potential difference between the lower end of the rod and a point at a distance small r. Relation between field intensity and potential difference, E equal to minus dV by dr, from which we get dV equal to minus E dr. So potential difference V equal to integral dV, that is integral minus E dr. So integrating it from B to R, so integral B to R I rho by 2 pi r square dr. Upon simplification we get V equal to I rho by 2 pi into 1 by r minus 1 by b. An alpha particle is accelerated through a potential difference of 10 kilovolt. Then it enters into a region of transverse magnetic field of induction 0.1 Tesla, extended up to a distance of 0.1 meter. Determine the angle through which alpha particle deviates. Mass of the alpha particle is given to be 6.4 into 10 power minus 27 kg. Radius of the circular path followed by the alpha particle r equal to mv by bq, that is root of 2mk by bq, that is root of 2mqv by bq. By substituting the given numerical values, we get radius of the circular path to be 0. meter. The radius of the circular path is greater than the extension of the magnetic field. So the deviation produced will be theta equal to sine inverse x by r, which comes out to be 30 degrees.